case of SN1. Now there are various factors which affect the rate of SN1 and SN2 mechanism. First is effect of the structure of the substrate, whether the substrate is tertiary halide or whether it is a primary halide. Depending on the structure of the halide starting material, whether the SN1 rate will be faster or SN2 will be faster depending on that. Second factor is effect of the nucleophile. Third important factor is effect of the leaving group. And fourth factor is the effect of the solvent. Thus, these four factors, again I will repeat, effect of the structure of substrate, effect of the nucleophile, effect of the leaving group, and effect of the solvent. All these four factors affect the rate of SN1 and SN2. How it affects it, let us see, students. See here, whenever we are considering SN2 mechanism, if your substrate is primary halide, rate of reaction will be faster. Therefore, in CH3X, rate of reaction will be faster, then primary, then secondary, and then tertiary. In case of tertiary halide, the rate of reaction is very less. Why? Because if tertiary halide is there, then in SN2 mechanism, there is a backside attack of nucleophile. If the groups attached to the carbon are bulkier in size, then there is a strong steric hindrance. Then backside attack of nucleophile become difficult due to the strong steric hindrance, and therefore rate of SN2 in case of tertiary is very less. Steric effects, as I told you, if number of R group attached to the carbon, this carbon there are hydrogen. If instead of hydrogen R are there, if more number of R group are there at alpha carbon, then crowding will increase. If crowding will increase, then backside attack of nucleophile become difficult due to the strong steric hindrance, and therefore rate of SN2 will decreases. If number of R group increases at alpha carbon, due to steric hindrance problem, backside attack will become difficult and rate of SN2 decreases. In case of SN1 mechanism, whenever we are considering, then order of reactivity are as follows. Tertiary will react faster, then secondary, then primary, and then methyl halide. In case of SN1, first step is the formation of a carbocation. Therefore, the carbocation, if stable by any effect, inductive effect, resonance effect, or any other effect, then it requires less energy, energetically favorable, and then stability of carbocation more, rate of SN1 will be more. Therefore, how the substrate structure of the substrate affect the rate of SN1? If the R group attached to the carbon, that alpha carbon is increases, then plus I effect, inductive effect will also increase. Also, due to plus I effect, plus resonance effect, electron donating resonance effect means electron donating group attached to the benzene ring, such substrate, or hyperconjugation, more number of alpha hydrogens are present in the substrate, then due to all these effects, plus I, plus R, and hyperconjugation effect, the carbocation gets stabilized, and due to that it favors the SN1 mechanism than SN2 mechanism, and therefore rate of SN1 will be more in tertiary substrate. Tertiary halide substrate undergoes the SN1, form the carbocation. Also, whenever we are considering the starting material, alkyl halide, it is sp3 hybridized. Its bond angle is 109 degree. While whenever it converted into carbocation, carbocation is a planar, as you know, therefore its bond angle is 120 degree. Thus, whenever substrate converted into the carbocation, there is an increase in the bond angle from 109 to 120 degree. That means in starting material reactant, suppose more number of methyl groups are there, the crowding will be more. But whenever it converted into the carbocation, the angle is increased 120 degree. Therefore, that methyl group gets sufficient space to accommodate, and therefore there is some relief from the steric strain whenever the substrate converted into the carbocation, and therefore rate of SN1 will be more. Thus, we can say SN1, if crowding at alpha carbon increases, rate of SN1 also increases. Now the second factors we are going to see, that is effect of the nucleophile on rate of SN1 and SN2. In case of SN2 mechanism, as you know, the rate of SN2 is directly proportional to concentration of a substrate as well as concentration of the nucleophile, and this is the rate determining step. It is only one step process. Therefore, rate of SN2 reaction depends on the concentration of substrate as well as concentration of the nucleophile also. And hence, this step is the rate determining step. Hence, the nucleophilic concentration affects the rate of SN2. Therefore, we can say if the concentration of the nucleophile is high, then it favors the SN2 mechanism, because in the rate law, nucleophilic concentration is there. And therefore, if concentration of nucleophile is more, or if it is a stronger nucleophile, then the rate of SN2 will be faster or more. While in case of SN1 mechanism, kinetic study shows that rate of SN1 is directly proportional to concentration of the substrate, and this is the rate determining step. In this rate law, the concentration of nucleophile is not there, because only first step carbon and Br bond breaks to form a carbocation. Therefore, nucleophilic concentration is not involved in RDS. Therefore, rate doesn't depends upon the concentration of the concentration of the nucleophile. It only depends on the concentration of substrate. The nucleophile is not involved in the rate law. Therefore, concentration as well as nature of nucleophile doesn't affect the rate of SN1 mechanism. Therefore, weak nucleophile can favor the rate of SN1 mechanism. Now, the another concept, that is the basicity and nucleophilicity. Exactly what is basicity? Whenever the base, we are considering basicity, it is defined as the equilibrium constant when it abstracts the proton. Basicity is concerned, base always abstract the proton. While we are considering nucleophilicity, nucleophilic nature, then the nucleophile always attack on the electrophilic carbon. That means electron deficient carbon. Therefore, nucleophile always attack on the electrophilic carbon, attack on carbon, while basicity, the attack of base always takes place on the proton. It abstracts the proton. Therefore, this is a basic difference between the basicity and nucleophilicity. There are certain criteria for the nucleophilicity. Means, if OH negative is there and if water is there, which is more nucleophilic? Now here, the rule is that the negativity depends on the, means nucleophilicity depends on if negatively charged nucleophile is there, the negatively charged nucleophile is stronger than the neutral. Therefore, in this case, OH negative is a negatively charged nucleophile and water is a neutral. Therefore, negatively charged species is more nucleophilic. Therefore, out of OH negative and water, OH negative is more nucleophilic than water. Also, the nucleophilicity depends on the electronegativity also. In case of ammonia and water, ammonia, nitrogen is less electronegative, while oxygen is more electronegative. Therefore, the nitrogen is less electronegative, therefore ammonia is more basic in nature than the water. Also, in case of iodine, bromine, chlorine, in that case, the nucleophilic nature of iodine is more. Why? Because it depends on the two factors. Iodine, I negative is a less electronegative. Okay? While whenever we are considering Br and Cl and F, the I negative is least electronegative. Also, its size of I negative is bigger. Therefore, polarizability also increases in that case. Therefore, due to the bigger in size of I negative and less electronegativity of I negative act as a good nucleophile. Now, students, we will discuss the remaining part in the next video. Thank you.